Welcome to Study Loop.
So for the first part, to find out the self-inductance, we can use U equals to Li squared by 2, where I is the current, L is the self-inductance, and U is the energy. So if we solve for L, which is 2U over I squared, and we know that U is 10 joules and I is 2 amps. So from there, we'll see that inductance will be 5 Henry. Now for part B, we can use the definition of inductance or self-inductance, which is mu naught, or if we look at example 30.1, we'll see that it's mu naught A, then we have n squared divided by the length. So here n squared is the total number of turns, but since we don't know that, we know that number of turns per millimeter, so we have to do some trick here. So we know that total number of turn is basically number of turns, which is little n per millimeter. So if we convert that to meter, it's 0.001. So that means if we multiply the total length with that, this will give us the total number of turns, right? So basically what we have here is mu squared A little n squared, which is 10 for our case. So this is 10 coils per millimeter. So this number n here is 10. And then we have L squared times 10 to the power negative 6. And we divide that by L. So if we get rid of L here, we finally have L, which is equal to mu naught A n squared L. And from there, we can solve for little l. And if we do so, we see that we'll have 31.7 meter as our answer. And the way we get that here is we know that the value of n is 10 basically. So this is not 10 per millimeter, but 10. Then A is the area. So we are given the diameter. So diameter is 4 centimeters. So the radius is 0.02 meter. So the area is basically pi r squared. So we can use that information over here. And mu naught is 4 pi times 10 to the power negative 7 Tesla meter per ampere. So we can use that information here. And L is 5 Henry from the previous part. So if we do so and solve, if we put all the numbers in this equation and solve for L, we see that L will be 31.7 meters. All right, thanks for watching. I'll see you.